Because the scalar product of two vectors a and b is denoted by a dot b. Because of this notation, the scalar product is also called the dot product. Although a and b are vectors, the product itself, the dot product, is a scalar quantity. That means it has no directions. So how do we figure out scalar product? So here is vector a and b, and the angle between those two is phi. To figure out a dot b, here is the equation. So a dot b equals to size of a times size of b times cosine phi. The size means the magnitude. Calculating the scalar product of two vectors. So here is the equation. What does this equation mean? So here is a and here is b. So we place b and a together. This is how we calculate the scalar product. So when I write this, I can also rearrange it. This is the same as size of a times b cosine phi. What is b cosine phi? Well, b cosine phi, look at the diagram, b times cosine phi. This is a component of b projected on vector a. So this length is the b component parallel to a. So it's the size of a times b component of that parallel to a. If I rearrange it, I put a times cosine phi times b because these two are equivalent, right? So a times cosine phi, it's really, take a look at the diagram, that is the vector a projected on b. That is a component of a parallel to b. So it's the size of b multiply the size of a projected on b. So that is how you calculate the scalar product. The sign of scalar product. So if phi is between 0 and 90 degrees, a dot b is positive. How do we know? Because cosine that phi is greater than 0. Or because b times cosine phi is greater than 0 because b projected on a is positive. So that's when phi is less than 90, greater than 0, a dot b is positive. Now, when phi is between 90 and 180, a dot b is negative. That is because b projected on a is negative. If b and a are perpendicular to each other, the dot product is 0. So when a constant force applies to a body that undergoes a displacement d, the work done by the force is a scalar product. W equals F dot d. So work is an example of scalar product. Remember when we learned work? So work done by the force is positive when the angle between force and displacement is between 0 and 90 degrees. It is negative. It's kind of like dragging it, like you're walking a dog, then you're doing the negative work. And here is like a waiter holding the tree, you are doing no work. Remember that? That is because work is the scalar product of force and displacement. Scalar product of unit vectors. Remember unit vectors? Unit vectors are vectors has size of 1 and only its only job is pointing to the directions. We have special unit vectors I, j, and k. So now let's first talk about parallel unit vector. I, what is I dot I or I dot negative I? Okay, let's take a look. I dot I is the size of I because its unit, its size is 1 times 1. The angle between the two vectors is 0, so cosine 0 equals to 1, so the answer is 1. Similarly, you can get j dot j is also 1, k dot k is also 1. What if the it's I times negative I dot negative I? Well, I and negative I, the angle is 180. Cosine 180 is negative 1. So I dot negative I is negative 1. And same as j dot negative j and k dot negative k. perpendicular unit vectors is I dot j. I dot j is 1 times 1 times cosine 90. Now cosine 90 is 0, so I dot j is the same as j dot I equals 0. All perpendicular vectors, the scalar product between those two is 0. Calculating the scalar product using components. So here we have two vectors A and B represented by the component form. How do we multiply this? Well, in this case, there is a dot product. Remember in the math you learned FOIL, so AX times BX, AX BY, AX BZ, so each term you separate it, so AXI times BXI, AXI times BYJ, AXI times BZK. Now you do the same thing for AY, then you do the same thing for AZ. Take a look at this. Remember, these are the parallel dot product. Parallel I times I dot I equals to 1. I dot j equals 0. Similarly, I dot k is also 0. So after you look at it, you can figure it out. All these terms, there are 6 terms, that's 0. So you only have 3 terms left. So what do you got? A dot b equals ax times bx plus ay times by plus az times bz. That is the scalar product using components. Let's take a look at some examples. Two parallel vectors. What is a dot a? Well, a dot a equals the size of a times cosine 0 degrees. It's a squared. How about anti-parallel? A dot negative a. The angle between a and negative a is 180. Cosine 180 is negative 1. So a dot negative a is negative a squared. Now how about a dot j? Well, that is the same. Remember the FOIL. So j times I is 0. J times j gives you 1. J times k another 0. So the answer is just ay. Let's do another example. Calculating a scalar product. Find the vector product a dot b of the two vectors in the diagram. The magnitude of vectors are a equals 4 and b equals 5. So here's 4, here's 5. By definition, a dot b equals ab cosine phi. So a is 4, b is 5. What is the angle in between? The angle in between is 130 minus 53. So after you put that in the calculator, you should have 4.50. Now we can use, remember I talked about angles. We could find angles in 2 dimensions, and angles for 3 dimensions is hard. But there is a way to find angle. We can use dot product to find angle. Let's see how we do it. So a dot b, there are 2 equations. Equals the size of a times size of b times cosine theta, also equals to the component. Okay, ax bx plus ay by plus az bz. How do we solve for cosine theta? We just move it around, right? What is the size of a? Ax squared plus ay squared plus az squared. And b equals to that. So from here, we can solve for cosine theta. And to find theta, we use inverse cosine. So basically, is the component scalar product divided by size of a times size of b. So if theta, cosine theta is negative, that means theta is between 90 and 180 degrees. Let's take a look at this example. So here are the 2 vectors given. There are 2 questions. What is a dot b equals to, and what is the angle between a and b? So a dot b, since this is in unit vector form, so it is just ax times bx plus ay. In this case, it is 0 times by plus az times bz. So you add, you multiply each set of components, and you should get a 4. How do we find theta? We use the equation we just derived from last slide, right? So we In this case, we already know what is A dot B. Let's find what is the magnitude of A and find what's the magnitude of B. Magnitude of A is 3 squared plus 0 squared plus 7 squared. And magnitude of B is 1 squared, the square root of -1 squared plus 2 squared plus 1 squared. So here is A, right? Size of A, size of B. You plug it in, you should have 77.6 degrees. Another example, this one is asking you to find the angle between the two vectors. Remember the equation? So this is multiple steps. First, you have to see what is A dot B equals to. Then you have to find size of A and the magnitude of A and the magnitude of B, then you divide. Finally, you do inverse cosine. So after you do everything, you should have 100 degrees. Now here is the last example. The dot product of two vectors. Is it a scalar quantity? Is it 0 if two vectors are perpendicular? Does it lie perpendicular to the plane defined by the two vectors? What are the choice? So is it 1 only, 2 only, 3, 1 and 2, or 1, 2, 3? So we know 1 is definitely correct because dot product is a scalar product. We know if the two vectors are perpendicular to each other, cosine 90 equals 0, so 2 is definitely right. Question is 3. Does it lie perpendicular to the plane defined by the two vectors? Now this is a scalar product. Scalar product has no directions, so it doesn't lie anywhere. So the answer in this case is 1 and 2 only. That's it. Thanks for watching. See you next time.